This is the first chapter of the 19C SQL Tuning for Developers course. This chapter is called the course introduction. The first topics that we're going to discuss in this course are the course objectives, the course outline, the prerequisites, and the activities that are being used within this course. After you have completed this course, you should be able to choose and find an appropriate SQL tuning approach. You should be able to gather suspected session statistics by using the SQL trace facility and interpret the captured tracing information. We're also going to see how we can identify poorly performing SQL statements, how to use basic tuning techniques to tune inefficient SQLs, and how to capture and interpret execution plans. We're also going to see the importance of the Oracle Optimizer in the world of SQL tuning. We're going to describe Oracle Optimizer fundamentals like the various phases that the optimizer goes through in order to generate an execution plan. We're going to see how we can influence the behavior of the optimizer by means, for instance, by setting parameters. We're also going to discuss the optimizer access paths, joins, and other operations. Plus, we're also going to have a listing of optimizer statistics best practices. One of the last chapters of this course is going to handle the management of SQL performance through changes. Now, this course is intended for experienced Oracle SQL developers or Oracle DBAs that require a much better understanding of serial SQL execution. Before you start this course, you should already have a good working knowledge and understanding of SQL statements. This slide over here gives an overview of the various chapters that are going to be handled throughout this course. We are currently busy with the first chapter, the introduction chapter, but it's in chapter number 2 that we're going to have an introduction to SQL tuning. In chapter number 3, we're going to discuss what is tracing, how you can use certain application tracing tools, and how to format the captured tracing information. In chapter number 4, we're going to discuss the optimizer fundamentals like query transformation, calculating selectivity, calculating cardinality. In chapter number 5, as well as in chapter number 6, we're going to put the focus on execution plans. We're going to discuss how we can generate, how we can capture and display execution plans, and also how we have to interpret those execution plans. In chapter number 7, we're going to discuss the table and index access paths, while in chapter number 8, we're going to talk about joins. In chapter number 9, we're going to discuss some other optimizer operators like the inlist operator or the buffer sort operator. In chapter number 10, we're going to have an introduction to the optimizer statistics, why they are important, how they are being captured, etc. In chapter number 11, we're going to discuss the utilization of bind variables. We're going to discuss the advantages as well as the disadvantages of using bind variables within your application code. In chapter number 12, we're going to discuss SQL plan management. We're going to see how we can control the evolution of execution plans. Chapter number 13 is a set of workshops that you can make to gain more real-life experience in the world of SQL tuning. There are also several appendixes available, but more about these at the end of this chapter. Now, throughout the course, there are going to be different types of activities to help you understand the concepts. There are going to be quizzes to test your knowledge of the important concepts in each chapter, practices to reinforce your learning through guided hands-on exercises, and like I've already mentioned on the previous slide, a workshop chapter to give you the opportunity to gain practical experience through problem solving. The second topic that we're going to discuss within this course are the sample schemas used within this course. Now, when following this course, you will have access to a practice machine where already an Oracle database has been installed, in which 3 sample schemas have already been provisioned. You have on one hand the human resources schema, the HR schema. You have the sales history schema, the SH schema, and the order entry schema, the so-called OE schema. Now, on the next couple of slides, you're going to have a brief overview of the different tables that exist within each schema and how they are related with each other by means of primary key, foreign key relationships. The first schema discussed is the HR schema, which contains tables like departments and employees. And here you get a very basic entity relationship diagram showing you the tables that exist within that schema. And it also shows which tables and how those tables are related with each other by means of primary key, foreign key. So this is the HR schema. There is also the SH schema, the sales history schema, where you get on this slide, as well as on the next slides, an overview of the tables that are provisioned within that schema, and also showing you which tables are related with each other and how they are related with each other. The final schema is the order entry schema, where you see that orders are being placed by customers. Several orders can be placed by one customer. Customer can place multiple orders. The third bullet of this chapter is going to discuss briefly your class accounts information. Now, like I've already mentioned in a previous slide, if you're following this course, you will have access to a practice machine upon which a standalone installation of an Oracle Database 19c Enterprise Edition has happened, in which sample schemas SH, OE, and HR have already provisioned. So during the exercise, you're going to log in as user SH or as user HR or as user OE. The passwords that you need to log in as SH and HR and OE match the account ID. So it means that if you have to log in as user HR, that the password that you have to use is HR. Same story for the SH user, the password is SH. Same story for the OE user, the password is OE. The fourth topic that is discussed within this chapter are the two SQL environments that are available within the course. So upon your practice machine, you have the Oracle SQL Plus tool, which is a command line interface, giving you the possibility to log in into the database, type in your SQL statements, and let them have them executed within the database. Also, we're going to see how in SQL Plus we can generate the execution plan and how we can display that execution plan. On the other hand, there is the Oracle SQL Developers tool, which is a free graphical tool allowing you to establish connections to your database, type in SQL statements, execute them, and display those execution plans of the executed SQL statements. Throughout this course, you're going to make several exercises. Throughout this course, you're going to have several demos that are going to be shown. Most of the time, the exercises as well as the demos are being done by means of Oracle SQL Developer. The last topic of this chapter handles an overview of the workshops, the demos, the code examples, solution scripts, and appendixes that are being used within this course. Now, when following this course, like I've already mentioned earlier, you will have access to a practice machine. On that practice machine, you have an already installed database. There are sample schemas foreseen inside that database, but also upon that practice machine, several folders are being provisioned in order to make the workshop, in order to make the exercise. Now let me just show my practice environment, and there you have a folder home. When you open that, you can go to other locations, you go to computer, there you have a folder home, where you have a folder Oracle, and there you have a folder labs, and it's underneath that folder you will find the folders that are mentioned upon your slide. And for instance, there is a folder solutions, which contains quite some other subfolders, like the application tracing folder. Now, it's that folder, the application tracing folder, that contains the script files that you will need to launch when making the exercises of chapter number 3. So each practice that you're going to make has its own solutions folder. Which solutions folder to use will be mentioned at the beginning of every practice. There are also 6 appendices foreseen within this course. You have Appendix A that discusses in more detail the utilization of SQL Developer. Appendix B and C explains what is the SQL Tuning Advisor and what is the SQL Access Advisor. Appendix D explains the architecture and the terminology that comes along with an Oracle database environment. Appendix E discusses the real-time database operation monitoring. And the final appendix discusses how we can gather and how we can manage those optimizer statistics. Workshop 1 of the SQL Tuning for Developers course. In this workshop, you will perform tasks such as analyzing an SQL query statement, creating a new index, and perform some additional tasks. There are several scripts to be used to complete this workshop. Those scripts are listed within this workshop guide. So in this workshop, you have to find a workaround to enhance performance. You analyze a poorly written SQL statement and perform additional tasks such as creating a function-based index, redesigning a simple table, and rewriting the SQL statement. Now, the environment to execute this workshop is SQL Developer. And for this workshop, you need a connection as user HR. Now, in my SQL Developer environment, I have already made a connection called HR_connection, where I'm establishing a connection as user HR with password HR to my pluggable database ORCL PDB. Also, all the necessary scripts that you need to use for this script are located underneath the workshops folder. Now, what you're going to do is in SQL Developer, you go to Tools, you go to Preferences, underneath the database mode, you click upon the worksheet property, and there you make sure that the default path to look for scripts points to the directory Home Oracle Labs Workshops. Once you have done that, go to your Files view, click upon My Computer, and refresh. After that action, the Workshops folder should be reflected in the Files view. If the Files view is not at your disposal in your SQL Developer environment, go to View and open the Files view. Also, to make your life easy when performing this workshop, open the necessary script files beforehand in the order as mentioned inside the workshop guide. So the first one that I will need to open is setup01.sql. We'll go to your Files view, expand the workshop folder, and double click setup01.sql, and it will open that script file. Then I need to open ws01.sql script file. We'll look it up in your workshops and double click it. And you do that for every script file that is mentioned in your workshop guide. Now you're ready to start the workshop. So the first thing that you will need to do is you will have to run the script setup01.sql to set up your environment for this workshop. So what you do is I go to my script file setup01.sql, make sure that I've selected the HR connection, and you're simply going to run the script. What is this script going to do? Well, it's going to create a table emp, which is an exact copy of table employees. Plus, you're going to create a table depth based upon the result of this query upon table departments. Also, it will then create an index upon the dept ID column of my table dept. The index name is dept ID IDX1, and it will also gather the table statistics upon table emp as well as upon table dept. Also, something that you need to know for the workshop is when I'm looking at the description of table emp, I'm seeing that there is a department ID column of the number data type. While if I'm looking at the description of table dept, I see that there is a dept ID column of the data type character. Now later on we're going to perform select statements that joins emp and dept based upon the department ID column of emp and the dept ID column of table dept. But both columns do have a data type mismatch. One is numeric data, the other one is character data. So launch the setup01.sql script file. Then what you're going to do is you have to review and check the execution plan for this particular select statement by means of SQL Developer. Well, what you're going to do is you take this ws01.script file. So I've already opened this. You see it's a select statement upon table emp and dept, and they are being joined based upon the department ID column of emp and the dept ID column of dept. Make sure that you have chosen the HR connection, and then in SQL Developer you're going to click upon the button Explain Plan. And it will show you the execution plan rendered by the optimizer for that particular select statement. And what do I see is that it performs a full table scan upon dept, a full table scan upon emp, and those two results are joined together by means of the hasJoin method. Now there is another way to review the execution plan of a particular select statement. What you can do is you can use also the explain plan SQL command to find out the execution plan for a particular select statement, and then use the function display of the package dbms explan to show the execution plan of the last explained SQL statement. For this we can use the script file w1s1e.sql. So here is that script file, and I'm going to execute the explain plan command for the select statement, which is the same select statement that we have explained via SQL Developer, and then call upon the display function of the package dbms explan to show that execution plan. Make sure you choose HR connection, and now you're going to run the script. And what do you see is that the statement gets explained, and it shows you via that function display the generated execution plan, and as I can see, 2 full table scans of which the results are combined together via the hasJoin method. I'm seeing exactly the same thing as with the previous demo. Now I'm seeing in the execution plan that the index upon the dept ID column is not being used. So they're asking you here, was the dept ID IDX1, which is an index upon column dept ID of the table dept, has it been used? No, because it doesn't pop up in the execution plan. And why did it not use it? Because the dept ID column is being used inside a function. So there is going to be an internal transformation upon the data of that column dept ID, making the index unavailable to be used. So the index is not used, and internal transformation due to the function has occurred on the indexed column. Now what you can do is you have the possibility to create a so-called function-based index, and that's an index that will index the result of that function upon the dept ID column. Well, we're going to create the index dept ID IDX2, which is a function-based index. To do so, we can use the script file ws01a.sql. So here is that script already open. Choose the HR connection and run the script. And you see that at the function-based index, which is dept ID IDX2 that it has been created. And then what we're going to do is we're going to again explain that selects it and see if the generated execution plan uses that newly created index. Going to use ws01a.sql script file in order to do so. So here, explain plan, after I've created the index and display it, choose the HR connection. And what do I see is that he's still not using that new index, although it's a function-based index. Yeah, but the index is not being used because I've told you at the beginning of this workshop that this column is numeric data, while that column is character data. That means that there's going to be an implicit data type conversion while executing that select statement, making any index, even the function-based index, unavailable. So when I'm running that script file, explaining that statement again, I still see that the index is not being used, and the reason is because of the data type mismatch between the department ID column of the M table and the dept ID column of the dept table. Now, what you could do is you might try to rewrite the SQL statement, or even try to redesign the dept table so that that dept ID column has the same data type as the department ID column. So check all the columns which matching data types. And then you can create an index on the dept ID column, and via the explain plan, check the execution plan if the index is being used. At the end of this workshop, you will have to launch the script file cleanup01.sql to clean up your environment for the next task. So the cleanup script, choose HR connection and run the script. Now there are a couple of questions that needs answering, like the first question. After a function-based index is created, it is always chosen by the optimizer even if there is a condition that forces implicit data type conversion. Yeah, the answer is false, because we have seen that although I had a function-based index, it was not used due to the fact that there was an implicit data type conversion of the dept ID column. Also, when computing selectivity on predicates of the form function equals a constant, the optimizer will assume a static selectivity value of 1%. The answer to this question is also false, because when you run the setup file, at the end it gathered optimizer statistics on both table emp and table dept, and he's going to use that to calculate selectivity and cardinality. If there were no optimizer statistics collected, at that moment in time, when the optimizer builds the execution plan, he will assume certain defaults for selectivity and cardinality estimates.